This is problem 1, and what we're supposed to do is determine whether the correspondence is a function. Now look at this correspondence. 6 goes to 14, 2 goes to 25, and 22 goes to 14. To answer this question, we surely need to know what a function is. So here's the definition of a function. A function is a correspondence between a first set, called the domain, and a second set, called the range, such that each number in the domain corresponds to exactly one number in the range. Okay, now, a lot of words. Let's see if we can make sense out of it. So take part of it at a time. So first of all, here's what a function is. It's going to tell us. You have a first set and a second set. Now, the first set here is this collection of numbers, 6, 2, and 22. So we've got that set. Now, that set is called the domain. Then you have a second set, right? You have over here a second set. We're going to call that set the range. So we have two sets. One's the domain, one's the range, and the range in this case is 14 and 25. So you have a correspondence. Now we have a correspondence here, right? 6 corresponds to 14, 2 corresponds to 25, 22 corresponds to 14. But there's a condition. The condition is this. Each member of the domain corresponds to exactly one member of the range. All right, so each member of the domain, so each one of these members corresponds to exactly one member of the range. Now the question is, do we have that here? So what we're saying is that every one of these elements here has to correspond or go to exactly one element over here. Now, do we have that? What about the 6? The 6 goes only to 14, nothing else, exactly 1. 2 goes only to 25. Yeah, so 2 goes only to one element. And what about 22? 22 goes to exactly one element. So every element here goes to exactly one element over here. So I'm going to say, yes, this is a function. Problem 2 asks us to determine whether this correspondence here, the correspondence between the names of these law firms and the number of partners they have, is a function. So a function, remember, is a correspondence between a first set and a second set. So we have that. We have a first set. This set is the domain. Second set is the range. Now the question we have to answer is this. Is every one of these elements, these law firms, associated with exactly one of these numbers of partners? Well, look at Peter, Young, and Company. They have exactly 856 partners. It doesn't say that they have 856 and 857. It doesn't say that. All right? They have only 856. What about this one? This one has only 936. This one has only exactly 771, and so on. Each one of these has exactly one number related to it. So this here corresponds to exactly one here, and so on. So I'm going to say, yes, this correspondence is a function. Number 3, here's our domain. We have two sets. We have a domain and a range. Now, actually, I'm going to make a drawing here. I think that might help. Helps me anyway. All right, so here's a domain. And what's in our domain? The domain is a set of people, right? So the domain, what do we have? We have a set of people. So what's in here? You've got people. Okay, like maybe you have person 1, person 2, person 3, so on. And our second set, this is the range. Our second set is, here's the range, a set of dates. All right, so you have dates in here. So what are we going to have in here? Maybe you have like January, let me write January 1st, January 2nd, January 3rd, ... all the way up to December 25th. Right, you have those dates. Now, the question is, do each one of these, can you associate each one of these with exactly one of these? All right, well, I think so. Do you think? Person 1. Person 1 is going to have exactly one birth date. Maybe it's January 3rd. Person 2 will have exactly one birth date. Maybe it's January 4th. Person 3 will have exactly one birth date. Maybe it's actually January 3rd again. But the point is, this one goes to exactly one item. This one goes to exactly one item. So I'm going to claim, yes, this is a function. Now here's where it would not be a function. I mean, I don't think this can happen, but what if person 1 had a birth date of January 3rd and a birth date of January 2nd, right? Can't happen, right? No way. No way that can happen. So every item over here gets associated with exactly one item over here. Now in problem 4, we're going to determine again if this relationship is a function. So here's the domain. The domain is each person in a family, and the range is a set of daughters. I'll make a drawing here. So here's the first set. This is the domain. And what do we have? Members of a family. So maybe there's member 1, member 2, member 3, maybe there's 8 people. It doesn't matter. Just there's some number of members in a family. And then the second set is the range, and we have a set of daughters. So maybe there's daughter 1, daughter 2, daughter 5 maybe. Number 4, we want to determine if this relation is a function. Identify the domain and the range. Now what we have here is a set of ordered pairs. We have this pair, -4 goes to 1. All right, that's how I read these, is -4 goes to 1, 4 goes to 1, 6 goes to 1, 8 goes to 1, -6 goes to 1. Looks like all these numbers somehow get converted to a 1. I'm going to draw a picture here. Here's the domain. All right, here's the domain. The domain is the first elements in a set of ordered pairs. You have the domain element and the range element. So what are the domain elements? They're all the first elements. So I got -4 and 4. Right, we've got -4, +4. Then we have 6, 8, and -6. All right, so we have 6, 8, -6. Now the range, this is the collection of all the second elements. So look at the second elements. Well, they're all 1s, right? So there's only one element in the range. Only one element in the range, and it happens to be the number 1. Now what happens here? -4 goes to 1, so -4 goes only to one element. 4 goes to one element. Happens to be the same element, but still it goes only to 1. The 6 goes to only one element, the 1. 8 goes to only one element, and the -6 gets mapped or converted to only one element. So yes, this is a function, right? This is a function because every element in this set gets transformed to exactly one element in this set. Now, just so you know, what if we were to do this? What if we were to add another element in here? What if there was a 2 in here? And then you said that -6 goes, right, -6 goes to 1 and it goes to 2. Well, this relation does not represent a function because you have one element in the domain getting mapped to more than one element in the range. All right, we don't want to take too much time with these non-functions because it's ambiguous. If you want to put in a -6 and convert it, you don't know if you convert it to a 1 or a 2. It's ambiguous.